Alright, so we're going to continue talking about the confidence interval and construction of the confidence interval. And we've already kind of done it, but I didn't really go over the steps that we use to, and what it's labeled as for the 4-step process that we use in calculating our confidence interval. So with that, there's a 4-step process called state, plan, do, and conclude. In which case, we pretty much did everything. The only thing we kind of left off was conclude. I kind of voiced it in the other lesson, but we're going to write it out because that is the key thing that you're looking for once you actually get all the calculations done. And on your test is what's graded for. You need to get this 4-step process because that's what I look for in calculating these. You need to be able to classify the state, plan, do, and conclude process. So with that, let's look at this. In this example we did, for the first part, when you want to state, the state is concluding the population, parameter, sample, and statistic, which we've already gone over for everything we've looked at here when we did a random sample of 50 ballots for the presidential election. So let's write out this process here. Let me get my pen going again. Here we go. Okay, so our state. So in the state part, I'm going to list everything we did in the beginning. The population, parameter, statistic, and proportions. So the only thing we left off on this was initially when I talked about being 95% confident. So again, we left off the confidence level, right? So we were 90% confident, right? So we were 95% confident. So therefore you put in your 95% confident. Okay, so that's what we're looking at, our state part. Then we went into our plan, which in the plan, you're going to check off those 3 conditions that we talked about being random, 10%, and large counts, but there's one other thing. You need to name the procedure. And in this case, the name that you would take on, we did a 1-sample z interval for p, in other words, for a proportion, right? We call it a z interval because we use our z star doing proportions, so it's a z. So that's just something you have to remember. So one thing you kind of just have to kind of put in your head. So we did a 1-sample z interval for p. That's for a proportion, right? So you need to name it. Then we're going to go on. Again, we dealt with our random. We had random, 10%, and large counts. So again, as we put in there, yes, we had a random sample. Our sample of 50 was passing the 10% condition, and we passed our large count. So we had greater than or equal to 10 in both situations. So all 3 of those conditions have to be met, and you need to name the procedure that you're using for the confidence interval. So we got state, plan done. Now we're going to look at doing the do part. So on do, of course, that is actually all your calculations. The do part is all your calculations you're going to work on. Okay? The main thing they want to find out in your do part is seeing your point estimate plus and minus your margin of error. Now, you need to write your base formula, and there you go. You can write that exactly right there beforehand before you actually put the numbers in there so they know where you're going with this. Or you can write out that your p hat is plus and minus your z star times the square root of your p hat. 1 minus your p hat all over n. Okay? You can write out either one of those, or both if you want to. And then you're going to actually do the calculations to calculate your interval. Okay? In which case we would have done all that. Now, you don't need to show how you calculated your Z star. A Z star is understood to be 1.96 for 95% confidence, but you'll need to know that you use the inverse norm. To find that if you don't remember that, okay? That'd be the function to calculate for your 95% if you did not know that offhand. Again, it's going to be the same number. It's always going to be 1.96 for 95% confident, okay? So with that, that's how we came up with our interval. Now, this again, the 0.23 or 0.283 to 0.557 is your interval that we used for being 95% confident. The last step that you're going to worry about doing here is actually your conclusion, right? So, state plan doing a conclude. So you're going to do your conclude. Okay? So when you conclude this, all you're doing is stating what you've calculated. In this case, you would say, we are 95% confident that the interval from 0.283 to 0.557 captures the true proportion of Biden votes in the presidential election. Again, this is a statement that you kind of just got to put to memory. It's one thing we asked you to put to memory besides actually naming the procedures and the plan part. This statement, which you will get used to it because you're going to write it a lot. So again, you're always going to need to know, label your confidence level right there, okay? Then whatever interval is from whatever value to whatever it adds up to, captures is a key word to put in there, captures the true, in this case you're doing proportion, so true proportion of, and then your context, okay? So then all your context for the Biden votes and the presidential election, okay? So therefore you need to have your confidence level in there, your interval values, and then the context of what all that is pertaining to. Those have to be in there, okay? So again, with this, that is a 4-step process. State, plan, do, and conclude. So if you're looking at that and going through on this and asked to do a confidence interval, you do those 4 steps: state, population parameter sample statistic, your confidence level, your plan, in this case you're naming your procedure, checking off your conditions, the do part, the actual calculations to calculate your interval, and the conclude, making your conclusion statement on the with the figures that you found for your confidence level. Now one other thing here is, in this case, in the problem, if we look back at the problem initially, I came up with our point estimate, right? Our p-hat of 0.42. So I just came up with that, just a random number I came up with. But what if they don't give you that? What if they don't give you a p-hat value? So if you don't have this p-hat value, if this is not given to you, use 0.5. If you use 0.5, if you look at the big ideas, it will say that that is a conservative value, okay? So again, if p-hat is unknown, use 0.5. P-hat is unknown, use 0.5. Okay? Let me just write that out a little bit better instead of saying 0.5. Use your p-hat value is equal to 0.5. Okay? Now also too, one other thing is if you're ever solving for n, so in which case, let's say you're in the do part and they give you all information. They give you your p-hat data. They tell you your interval. They give you a confidence interval. and they go off of this, and they're wanting you to find your end value. Again, that is your sample size, right? Well, in this case, like we're talking about votes, you can't have a decimal of a vote, right? So always round up. Okay, so when you solve for n, if you ever have to solve for n, made that r look pretty bad. Solve for n, you're gonna always round up. Always round up. So in which case, if we would have solved for the amount of ballots we used, if we would have came out with 46.21, well, then we had said we had 47 ballots in this case if we would have solved for n, okay? So don't forget that. That's in your big ideas as well, to make sure to put in the back of your mind there and always think about that. But the big thing to take away from this is your 4-step process of state, plan, do, and conclude. And then also understand that you still need to use your margin of error is going to be your z star times your standard error. And then definitely putting in memory the conclusion statement and putting in your confidence level and your interval values, as well as the context within the problem. Those have to be stated to get credit for any type of problems you looked at for doing these. Okay? Alright guys, so that covers our 4-step process dealing with confidence intervals. Hope you learned a little bit of something. I'll see you next time.